Hi friends, welcome to this live session. I hope you can hear me. Yes, thanks. I see a lot of people have joined in. Hi, Avigna Daruka. I see Badal Kumar, Jay Gondalia. So welcome to this live session. I hope you can hear me. So that's great. And in this live session, we'll be doing a physics revision for class 10 CBSE. We'll be going over some important questions and I'll be showing you tips and techniques on how to solve the questions. Hello everyone. I can see you. Everyone's on the chat here. Hello Keshav Jindal. Hey Sugan Ranjit. Hi Akshat Swami. Hello. Yes, I'm also super excited because this is my first live session and I hope you guys are excited too. So we'll be doing some important questions for your physics exam, which is coming up soon. So I suggest you to sit with a pen and paper and you can solve them as we go along. Yeah, hello. Hi, Sonika Kindra, Prince Chen, Manisha Singh. Hello. Hi, everyone. Good evening. Good evening. Yes, I'm also super excited like you. So before I begin, first of all, I'd like to say a big thank you from our side for all the love and support that we've got from all of you. I must say, we are humbled by your response, and it's amazing to read your comments and feedback. It's really very motivating. You know, it motivates us to make more awesome videos for all of you. Big thank you for all of you, you know. Yes, hi Goranji, Bella Tony, hello, I can see you. And Naresh Sirvi, Noman Siddiqui, hello. And there's Nevedita Singh Patel. So thank you friends, everyone for joining in. And as I said, we'll be going over some important physics questions. So get your pen and paper ready. We'll be solving them, you know. Thank you. It's great. Yeah, thanks. It's our first live session, so it's really awesome to be here. And now Manocha Academy is a family of over 120,000. Yes, we are a family of 120,000 people. There are 120,000 subscribers on our channel. So I really want to say a big thank you to all of you. And I know a lot of you are having exams right now or will be having exams. So wishing you all the very best for your exams. And as I said, just go and give it your best shot, you know. Don't worry about anything. And as I said in one of my videos, it's okay to feel excited and tense during the exam. Everyone feels a bit tensed. You're not alone. But my advice would be just focus on doing your best. You know, forget about the rest and just focus on giving your best in the exam. It's your time, it's your effort, and just put in all the hard work. That would be my suggestion. Yes, thank you, Saharsh. I see Neha, Badal Kumar. Hello, everyone. Sorry if I'm missing your name, but you know, it's really awesome that everyone's joined in for this live session. And please do hit the like button if you haven't hit it already. And do share this live session with your friends if they can join us now, or maybe they can watch the replay. That'll be awesome. So thanks a lot. Hi, Vishnu Mehrotra, Harshit Singh, Rakesh, Sharat, Rujul, hi Shobit, Sonika Kundra. So we have a lot of people here. Hello from Chandigarh. We have Ayushman Ganguly. And Vadhuvan Kunhi is here. Hi. Bhargavi Punari. Hello. Hi, Rishu Kumar. So I'm just giving a couple of minutes for more people to join in, and we'll just get started very soon. And as I said, all the best, you know, for your exams. And thanks a lot for watching the videos. And I mean, when I read the comments, it's awesome to see such great feedback. It really motivates us, and we are really humbled by your response. So thanks a lot from Manocha Academy. And I've recently uploaded, some videos. So if you haven't watched these are pretty helpful for your exams. So I have one how to study one day before the exam, or how to write your exam to get good marks. So if you haven't watched these videos, guys, do check it out. I think it'll help you, because you do know these tips, but sometimes we forget it during the exam. So it's a quick revision. These videos are pretty short, just 7 or 8 minutes. So do check it out. And I have some special class 10 videos like on electricity numericals. There's IUPAC nomenclature, and how to write organic reactions, or how to remember them, So do check out the videos on our channel. And I'll also put a link to these videos in the description below once the live session is over. Hi, Arman Singh. Hi. Hi, Jatin Sarmal. Hello. Hi, Ankush Gupta. So hello everyone, hello, welcome. And as I was saying, so if you've just joined in, do check out these videos, and do share it also with your friends. All right. And before we get started, one more thing, I do have my website also, manochaacademy.com. So there we have a lot of quiz and questions for you to practice. So you can go in and sign up on this website and use it. And I'm sure it will be helpful for you for your exam preparation. Hi, Debashish Bose. Hi. Who else do we have here? Raja Naveen, Monu Prajapati. Hello, hello. Bhanu Sridevi. Welcome, everyone. Welcome to this live session. And we are just about to get started really soon. Okay. So get your pen and paper ready. I have mine ready. And you get yours ready. And let's go ahead and solve the questions together. Okay, so I'm going to get started. Sorry guys if I didn't get a chance to take your name, but it's awesome to have so many folks here. And please hit the like button if you haven't hit it already, and share out this video. So let's go ahead and start with the session. So here's our first question that we have up here. So what type of mirror is used for a solar furnace? So here are the options. Is it a plane mirror, convex mirror, or a concave mirror? What do you guys think? Right? Good. So I'm seeing many of you are answering it is concave mirror. So how to approach this question? What does a solar furnace do? You know that it's used to heat up, to achieve a high temperature, right? And what do we need for achieving a high temperature? We need a concave mirror, right? So why is that? Because as you know, a concave mirror is a converging mirror, right? So all of you know that concave mirror is a converging mirror. So when the sunlight rays fall on the concave mirror, so what happens? They get focused at a point, right? So you know that the rays will get reflected by the mirror and they'll meet at a point. And what is this point called? It's called the focus of the mirror, right? So here the correct answer is going to be C, concave mirror, because a concave mirror is used to converge the light rays. And that's why it's used for a solar furnace, right? Okay, so let's move on to the next question. So here's our next question. If a wire is stretched to 3 times its length, what is the change in resistivity? So if you take a wire and you stretch it to 3 times its length. So first let's visualize the question. So let's say we have a wire here of length L. So let me draw the wire. And the length of the wire is, let's say, L. And it has an area of cross section A. Now if we stretch this wire, so imagine you're pulling the wire, you're stretching it to 3 times its length. So the length is going to become 3L, right? And what will happen to the area of cross section? Everyone, what do you think is going to happen to the area of cross section? It's going to be A by 3, right? Because the wire is like Play-Doh or like clay. So when you pull it, the area of cross section changes. But the question asks us, what is the change in resistivity? So do you remember what is the symbol for resistivity? It's rho, right? So they're asking, what is the change in resistivity? And good, I can see a lot of you are answering that there's going to be no change in resistivity. That's absolutely the right answer. Why? Because we know that resistivity depends only on the material and the temperature of the wire. So it only depends on the material and temperature of the wire. And in this question, you're just changing the shape of the wire. So the material hasn't changed, the temperature hasn't changed. So this is a trick question. There is no change in resistivity. Yeah, that's the right answer, right? No change in it. But if the question was what is the change in resistance, then you need to apply this important formula. Remember, R equals rho L by A. Okay, so what will be the resistance of the original wire? If we mark that as R1, that's going to be, R1 is going to be rho L by A. And the resistance of the new wire R2 is going to be rho 3L, right? Because can you see the length is 3 times and the area of cross section is A by 3. And how do you find the change? Very simple, just take the ratio R2 by R1. And when you take the ratio R2 by R1, all of these things will cancel, but the number 9 by 1 will remain. So the change in resistance is going to be 9 times because R2 will be 9 times of R1. And that makes sense because when you increase the length 3 times, the resistance will go up by 3 and resistance is inversely proportional to the area of cross section. So we made it 1/3. So that's another 3 factors, right? So that is the change in, but resistivity does not change. Now let's move on to the next question. Okay, so guys, try this question. You have 3 resistors, 1 ohm, 10 ohm and 100 ohm, and they are all connected in parallel. So what will be the total resistance? Will it be 0 ohm, between 0 and 1, between 1 and 10, or is it going to be greater than 100 ohms? So what do you think is going to be the answer here? So let's visualize this question. In electricity, it's always important to draw a diagram. So let's say you have a 1 ohm resistor, a 10 ohm resistor, and a 100 ohm resistor, right? So we have these 3 resistors, okay, and they're all connected in parallel. So what do you think will be the overall resistance here? So one option, you know that we can apply the parallel formula, which is 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3, right? That's the parallel formula and you can find the resistance. But this question is a little interesting because if you sit and solve it, it'll take some time. You'll have to substitute the values and calculate. What you can actually do here is apply the important concept that when you take resistors in parallel, the overall resistance will be lesser than the least resistance. Remember, just like in series, the overall resistance is greater than the maximum. But in parallel, what is the thing? The overall resistance is going to be lesser than the least. So now what do you think will be the answer here? Because they are connected in parallel, the least resistance here is 1 ohm, right? Can you see? The least resistance is going to be 1 ohm. And so the R parallel is basically going to be lesser than the least resistance. So it's going to be less than 1 ohm. So the overall resistance is going to be, and it can't be 0 ohms, right? Because you have 3 resistors. There's no path of just a simple path of 0 ohm resistance or no resistance. So the best answer here is going to be, it's going to be between 0 and 1 is the correct answer. And we did this without solving, applying the important concept that the parallel resistance will be lesser than the least resistance. Okay, so now let's move on to the next question. So this is the question. How many electrons are needed to charge a body to minus 3.2 Coulomb? Okay. So how do we solve this question? So what is the important formula here? Remember the important formula in electricity that we need to use? Q equals NE. Where what is Q? Q is the charge. N is the number of electrons. So the number of electrons. And E is the charge of one electron, right? So the charge of one electron. Right, so you need to apply this important formula Q equal to NE. And now we need to do the calculations here. So what is the charge given to us? Minus 3.2 Coulomb. Okay, we need to find the number of electrons. And what is the charge of one electron? It's minus 1.6 into 10 to the power minus 19 coulombs. So friends, please remember this important value. We need to learn this value of what is the charge of one electron. And now what will be the total number of electrons? It's pretty simple. We just need to divide it. So minus 3.2 divided by minus 1.6 into 10 to the power minus 19. And this is going to cancel out. So we have 2 and the 10 to the power minus 19 goes up there. So we'll have 2 into 10 to the power 19 electrons. That is our answer. So here the key concept is, usually in electricity you need to think, because you have a lot of formulas. So you need to think what is the important formula the question is asking. And in this one it's pretty clear. It's going to be the formula Q equal to NE. So when you apply it and substitute and calculate, and just be careful with the 10 to the power, the index maths, right, with the exponents. And so you'll get 2 into 10 to the power 19 electrons. Okay. Now let's move on to the next question. What phenomena is responsible for the twinkling of stars? So here are the options. Is it due to reflection of light, refraction of light, dispersion of light, or scattering of light? So this is our twinkle, twinkle, little star question, right? So let's say this is our star here. Okay, and when we look at the star, there are these layers of atmosphere between us, right? Let's say you're standing here and looking at the star. And so the light from the star is coming first through vacuum, so there's no bending. But when it hits the layers of the atmosphere, you know, there will be refraction happening. So there's going to be bending of light. I'm just drawing it roughly here to show you that light is going to bend. This is not an accurate diagram, but to show you the concept that in the layers of the atmosphere, the light from the star is going to bend. Good. So I see a lot of you are answering the right answer here in the chat. So it is due to the refraction of light, because we know that light bends, and it is the refraction of light phenomena that causes the twinkling of stars. And why is that? Because these layers of the atmosphere, so the layers we've shown here, they are not stationary. Their density keeps changing, the layers keep moving, their temperature changes, and so the rays of light do not follow one fixed path. Okay, so the rays of light keep bending, and the apparent position of the star keeps on changing. So the star would be here, and then its apparent position would be somewhere here, and then somewhere here, right? Because of the change in refraction of light. And this changing or fluctuating apparent position of the stars is due to the refraction of light. So the twinkling of the stars is caused due to refraction of light. Very good. I see a lot of people getting this question correct. So let's move on to the next question here. So this is an interesting question. We have two bulbs with rating 60 watt, 220 volts, and 40 watt, 220 volts are connected in parallel to a 220 volt electric supply. Find the current drawn from the electric supply. Again, in electricity, I highly recommend you need to draw a diagram, right? To visualize the question, please draw a diagram. Don't do all this mentally in your tests, right? So let's go ahead and draw a diagram here. So we have these two bulbs which are connected in parallel, okay? And this is a 220 volt electric supply. And the two bulbs, let me mark them. One is 60 watts and the other bulb is 40 watts, right? So we have these two bulbs here. And what do we need to find here? So what do we need to find? The current drawn, the current is I. So we need to calculate what is the current that is drawn from the electric supply. Okay. So here, how do we solve that? Because in parallel, we know that both the bulbs are getting the same voltage. So in a parallel connection, both of them are getting 220 volts and the current splits. So in a parallel connection, the voltage or the potential difference is same for the bulbs, but the current here splits into I1 and I2. Is that making sense, right? The current splits. So the total current I is going to be I1 plus I2, right? That's pretty simple. Now, if we can find the individual currents, it will be easy. So here, should we go for Ohm's law? Should we apply V equal to IR? What do you think? So here, actually, you don't even need to find the resistance, because the important concept here is you're given power, you're given voltage, you need to find current. So go for the power formula, right? So what is the important power formula to use? Let me write that here. P equal to VI. We need to apply that formula. So what will be the current in the I1? So I1 in the first bulb is going to be V1 by P1. Oh, sorry. It's going to be P1 by V1, right? And the current in the second bulb is going to be P2 by V2. Does that make sense? Right? So the current is P by V. And what is the power of the first bulb? It's 60 watt and that's 220 volts here. And the current in the second bulb is simple, 40 watts by 220 volts. Because remember, both the bulbs are getting 220 volts. They are in parallel. And we just need to substitute their power, the power values. So that's I1 and I2. So the total current I is going to be pretty simple, 60 by 220 plus 40 by 220, right? Okay, so that's easy. And then we just add it up. So that's going to be 100 by 220. And if you calculate that, we are going to get 5 by 11, which I think if you work it out, that's going to be 0.45 ampere. So that's the answer. Good. Some of you have got 5 by 11. And don't forget the unit in the exam. Don't end the answer as 5 by 11 or 0.45. What is the unit of current? Amperes. Okay. So this is how you solve the sum, and this is an interesting sum where we didn't use Ohm's law. Okay, we just used the power formula and found the current. And again, remember, in electricity, please draw a diagram. Okay, so please draw a diagram and calculate the current by visualizing the circuit. That's really important. Okay. Good. Yeah, I see some people have got 0.45 ampere, 5 by 11. That's really good. Okay, so let's move on to the next question. So why is the sky blue but the clouds are white? Okay, so this is the question, that why our sky appears blue to us but the clouds are white. So if we compare, let's compare the sky, okay, on one side, and let's say the clouds on the other side. Okay, and what is the important concept here? The sky is made up of tiny, tiny air particles, really tiny air particles. Okay, but the cloud is made up of much larger particles, which are comprised of the dust and water droplets. So the key difference is the size of the particles. Here the particle size is large, so large particles here. Okay, and the sky is made up of tiny particles. Okay, and these are less in size compared to the wavelength of light, the tiny sky particles. And what is the key concept here? That in the sky, when you have these tiny particles, they do preferential scattering. Good, I see a lot of people on the chat are getting scattering, and that is the key concept here, that there is preferential scattering for the tiny air particles. And what is preferential scattering? These tiny air particles, they scatter blue color more than the other colors, right? And that's why, so when light falls on them, so when white sunlight falls on the air particles in the sky, blue color is scattered the most. Okay, the other colors are also scattered, but blue is scattered the most because blue has the shortest wavelength. And this gives us the effect. So it appears that the sky is blue. The sky is not actually blue. It's due to scattering of light. But now when you come over to the clouds, what is the key concept? The large particles, like dust particles, they scatter. So when sunlight falls on them, they scatter all the colors equally. Okay, and so all the colors get scattered in all the directions, and so the cloud would appear white in color. So here there is no preferential scattering. All colors are scattered, right? And this is why the sky appears blue to us, but the cloud appears white. Okay, so again, you should look for what is the key concept they are asking you in the test. And here the key thing to write is about the scattering of light. Okay, very good. A lot of you got that. Now let's move on to the next question. A concave mirror produces 3 times magnified image on the screen, and the object is placed 20 centimeters in front of the mirror. Find the focal length of the mirror. Okay, so how do we do this question? So first thing, let's visualize it. Always draw a rough diagram. So here we have a concave mirror. Okay, and what are we given? That you have an object which is placed 20 centimeters in front of the mirror, and the image is produced on a screen. Okay, so here again I would suggest you, so get your pen and paper ready and try this question out, that by drawing the diagram, right? So try to visualize the question, don't just read it, right? And what do we know from, since the image is formed on a screen, what do we know about the image? Is it a real image or is it a virtual image? That's right, it's a real image, right? Because a real image is formed on a screen. Okay, and a real image is always inverted. So here the concave mirror is producing a 3 times magnified image, but it is going to be a real and inverted image, right? So let's write real and inverted. So what is our magnification going to be? Is the magnification going to be 3? So is it going to be +3 or -3? The answer is going to be -3, because you know that the image is real and inverted. So we are given that the image is 3 times, but since the image is inverted, we need to put the minus sign. So be very careful about the sign convention. You cannot write magnification as 3. Okay, and what is the object distance? So should I write 20 centimeters? No. Again, we need to use our sign convention. What is the sign convention, remember? So here if I draw the axis, this is the x-axis, x dash, y and y dash, right? So they're all centered at the pole of the mirror. So you need to use sign convention, and object distance is going to be -20 centimeters, right? And now you need to calculate the focal length. So let's apply the formula. So what is the formula for magnification? So we need to find the focal length. So focal length is unknown. And what is the sign of focal length? Whatever is unknown, the sign is also unknown. So don't bother whether it's positive or negative, that you're going to calculate. Okay, so let's go ahead and try it out. So magnification, so the first formula we're going to use of magnification, so m is going to be -v by u, right? So for a spherical mirror, that's our formula, and we apply it, let's substitute the value -3, and we are going to get, and we'll substitute the value of object distance. So what is our v going to turn out to be? It's -60 centimeters, right? And that makes sense because it's formed on a screen, so it's in front of the mirror, so it's a negative value. So v we've got, and we just need to find the focal length. And for that, let's use the mirror formula, right? 1 by f equal to 1 by v plus 1 by u. Is that right? That's the mirror formula. Now go ahead and substitute the values. So 1 by -60 and plus 1 by -20. So So let's take the negative sign outside, 1 by 60 plus 1 by 20, right? And what does that work out to be? So go ahead, do the calculations. It's pretty simple. 1 plus 3, and so that will be minus 1 by 15. So 1 by f is turning out to be minus 1 by 15. So therefore, what is the f? So f is going to be minus 15 centimeters. That is our answer here, right? Because we have to take, don't forget to take the reciprocal of the value. I think you can't read this, so I'll just rewrite it here. So here till now we found out was 1 by f. Okay, so f has turned out to be minus 15 centimeter. And does the answer make sense? Yes, because remember, a concave mirror, the focus is going to be on the left side. So it's on the negative x-axis. So you can quickly check your answer. You shouldn't get a positive answer. And when you're writing the answer in the exam, you can write f equal to minus 15 centimeter and then also write a sentence. The focal length of the concave mirror is 15 centimeters. Okay, so don't just leave it as minus 15 centimeters. Write the answer in a sentence form. That's an important tip for you to remember, that the focal length is 15 centimeters. Okay, it's like saying acceleration is minus 10 meters per second square or retardation is 10 meters per second square, right? So here you don't just leave the number, you write it in a sentence form where you don't need to take the minus sign. Great, let's move on to the next question. That's good. A lot of you got the correct answer. That's excellent. I see f equal to minus 15 centimeters there. Oh, and again, don't forget the unit centimeters. Don't end your answer just minus 15. Units are very important in physics. I see some of you are writing minus 15. Please write minus 15 centimeters, okay? We just don't care about the number. The units are equally important. Okay, let's move on to this next question. The refractive index of water is 4 by 3. What is the refractive index of air with respect to water? Okay. So let's write this as, what are we given first? That the refractive index of water, which means with respect to air, is 4 by 3, right? And what do we need to find? We need to find the refractive index of air with respect to water. Is that right? So write the here this n kind of symbol represents refractive index. And just to revise, what do these notations mean? So if you look here, this first one means refractive index of water with respect to air. Okay, and the next one is we need to find the refractive index of air with respect to water. Excellent. I see a lot of you are getting the right answer. So what is the main concept here? You need to apply the formula. Remember this formula, that the refractive index of 1 with respect to 2 is 1 by the refractive index of 2 with respect to 1. Okay, so therefore the refractive index of air with respect to water is going to be 1 by the refractive index of water with respect to air. So it's basically the reciprocal, right? So it's 1 by 4 by 3, which means the answer is going to be 3 by 4. That's our answer. Okay. So it's going to be the reciprocal of the value. So this one is pretty simple. You just need to apply the main formula. Now let's move ahead to the next question. A beam of electrons is flowing from north to south in a magnetic field, which is from west to east. Find the direction of force on the electrons. Okay. So again, to visualize it, physics is all about visualization. So guys, please draw a diagram. Okay. So let's draw a diagram for this one. So first let's mark the directions: north, south, and west, east. Okay. And what are we given? A beam of electrons, okay, is flowing from north to south. So let's draw our electron beam here. So that's our beam of electrons is moving from north to south in a magnetic field which is from west to east. Okay, so our magnetic field is from west to east. So this is our magnetic field in the green color. Okay, and electron flow is in the yellow color. Now you need to find the force on the electrons. Okay, so I want all of you to try this. So what do you think? What is the important concept here? How do you do this? So what rule do we need to use? That's right, we need to apply Fleming's left-hand rule, right? Why? So we need to apply here Fleming's left-hand rule, because we are interested in finding the force on the electrons. Okay, so here we are given magnetic field and electron flow means current is flowing, and when you need to find force, you need to go for Fleming's left-hand rule. And please remember in the exam, don't use your right hand, because then you'll get exactly the opposite answer. So tap your hand and make sure you're using your left hand for Fleming's left-hand rule. So while I'm showing it, maybe in the camera it looks opposite, but make sure I'm using my left hand here, and make sure you're using it. And remember, in the left hand, what's the rule? The forefinger represents the field, the center finger represents the current, and the thumb represents the force. Okay, so let's go ahead and apply Fleming's left-hand rule for this question. Okay, good. I can see a lot of you I think you're getting the right answer. So let's check it. So one important concept here, really important thing is, so the magnetic field is easy, right? So our forefinger needs to be aligned according to the, from west to east, right? According to the magnetic field. But the flow of current is going to be is it going to be from north to south? No, it'll be opposite. It'll be from south to north. Why? So the current flow, so let me mark that here. The current is actually going to flow. So let me mark it in orange. The current flow is actually going to be from south to north, because remember, conventional current is opposite to the direction of electron flow. And Fleming's left-hand rule, the key concept is it uses conventional direction of current, not electron flow, right? So it uses the conventional current direction. And so make sure your center finger is aligned from south to north. So your forefinger is this way, and then when you do that, let's say you've drawn this on the paper, then your thumb will be pointing into the paper. Okay, or some of you have written, I can see the answer you've written inside the earth, right? So if you're thinking of the earth as the surface, because we mentioned directions here, then it's inside the earth. So the force is going to be inwards here, right? So how do we write that answer? So one way to write is the force is into the plane of the paper. Into the plane of the paper, right? Or if you're watching it on a screen, so it's into the plane of the screen, or as some of you have written the answer on the chat, I can see inside the earth, right? So sometimes it's good to mention both the points, to express it. The force is inwards, it's inside the earth, or it's into the plane of the paper. So you're explaining the answer, the same answer in various ways. So it's best to mention the direction clearly, okay? Not just write inwards or something. Be as clear as possible. Okay, very good. So the key thing, guys, don't forget, one is whether to use Fleming's left-hand rule or right-hand rule. Here we are finding the direction of force, so it's Fleming's left-hand rule. And also you need to use the conventional direction of current, not the electron flow. Okay, so don't make the mistake, otherwise you'll get the opposite answer. Excellent. Let's move on to the next question. I think this one is an easy one. The sun appears red at sunset due to, is it reflection of light, B, refraction of light, C, dispersion of light, or D, scattering of light? Okay. I see a lot of comments here. I'm sorry I'm not being able to respond to each of them, but if you have doubts, please feel free to write it in the comments, once the live session is over, and I'll do my best to answer your doubts and questions. So I'm sorry I'm not being able to answer a lot of the questions on the live chat, because a lot of you are writing the answers and it's scrolling, but I'm trying my best here. And if you have any doubts about a specific question or something was not clear, do write it in the comments and I'll respond to them as soon as possible. Excellent. I see this one. A lot of you are getting the right answer. And what is the right answer? The sun is appears red at sunset due to scattering of light. That is the key phenomena here. Because remember, when you're looking at the sun, so when you're looking at the sun at sunset, the sun is near the horizon, right? Remember the concept that if you're looking at the sun at sunset, the sun is near the horizon. And so it goes through many layers in the atmosphere, right? So the sunlight is traveling through a large part in the atmosphere. And so there will be a lot of scattering of light, okay? And as we saw in that clouds, the sky and the clouds question, which color is scattered the most, right? It's blue, or actually it's violet, but we normally just consider red, green and blue usually. So that's why usually you'll see in the books it's mentioned blue color. So we consider blue is scattered the most and red color, right? So red color is scattered the least here. And that is why when the sunlight is coming towards us, it actually appears red to us. Oops, I'm using orange here, but anyway, I'll write that. So, red color is scattered the least. Okay, because of its large wavelength, red is scattered the least. So most of the red light reaches our eyes, and that's why the sun appears red at sunset. Excellent. Let's move on to the next question. A converging and diverging lens of equal focal length are placed coaxially in contact. So coaxially means on the same axis. What is the power of the combination? Okay, so again, let's visualize this. We have two lenses, a converging lens, right, and a diverging lens. So convex lens is a converging lens and concave is a diverging lens. And they are placed coaxially, means on the same axis, right, in contact. So what is the power of the combination? So what is the total power here? Okay, so how do we find that? So the key concept is we can add powers, right? So we can do, the total power is P1 plus P2. We can do that, but we can't do, you can't add up focal lengths. So powers can be added up when you combine. So remember that P equal to P1 plus P2 is right. You can't do F equal to F1 plus F2. That's going to be wrong. Don't use that, right? You can't add up focal lengths. So let's do here. So for the convex lens, it's going to be 1 by F. And for the concave lens, it's going to be minus 1 by F, right? And since both of them have equal focal length, we are not going to use F1 and F2. So what does they add up to, right? So if you take F, it's 1 and minus 1. So the total power works out to be, the total power is 0 or 0 diopter, right? So very good. A lot of you have got 0. So that is the right answer, that since they have equal focal length, the powers will cancel. The two lenses cancel each other out and the total power is 0 diopter. Excellent. Let's go to the next question. What is the frequency of DC current in India? So what do you think is the answer of this one? What is the frequency of DC current in India? Is it 0 Hertz, 50 Hertz, 60 Hertz, or 100 Hertz? So which one is the answer here? Be careful. This question is, it's not 50 Hertz, right? It's not asking, we are not asking the frequency of AC, it's the frequency of DC, okay? And you know that DC current, so DC current does not change direction. So no change in direction, right? Because it flows in a single direction only. So DC current flows in a single direction, right? And so when it flows in a single direction, there's no change in direction. So the frequency is basically 0. It's going to be 0 Hertz. So the correct answer is A. Excellent. I see a lot of A's there. So because here the direct current does not change in direction, has no change in direction, sorry. And if you take AC current, then you know the frequency is going to be 50 Hertz. So be careful, read the question carefully, you know, don't do careless mistakes. Now let's go to the next question. This is from the sources of energy chapter, right? Give 2 disadvantages of energy from the sea. Okay. So a lot of times on the sources of energy chapter, usually you'll get either the advantages or the limitations or disadvantages. So read them carefully because those are really important. And a lot of these things, you actually don't need to learn it up. You can sort of work out the answer or think the answer. So what do you think will be the 2 disadvantages of energy from the sea? Okay. What's going to be the answer here? Always try to write the most important points first. Okay. So one most important disadvantage is that it's location specific. So what do we mean by that? Because if you don't have a sea or an ocean, then you can't get energy from the sea, right? So not all places have seas and oceans, so they cannot get energy from the sea. So it's in limited places. That's right. I see that Rockstar VPS has written limited places available, right? Or you can write that as location specific. Very good. Okay. And what is the other disadvantage? So what is the other important disadvantages of energy from the sea? So do you think, I see someone's written very high tides, and also this question is not just about tidal energy or wave energy or ocean thermal energy, right? It's covering all the 3. So we are just considering any energy form out of these 3 from the sea, right? So we have to write an overall answer here. So one is location specific, and the second best disadvantage we can say is that the installation cost, right? So the installation cost or setup cost, okay, is very high. So it's expensive, right? Or you can say the installation is difficult to do, it's expensive, right? And another third disadvantage is that these, when you set up these things, it affects the marine life, right? So it adversely affects the marine life. So the important thing in the exam is write the important points first, okay? And try to give the 2 most important disadvantages that you know, not just any 2, right? And here I would suggest to write the first 2 in this answer. Okay. Now let's go on to the next question. How do you convert an AC generator into a DC generator? So how do you do this? So here we are talking about, we need to convert an AC generator, okay, into a DC generator. So the key concept here is think about the difference, right? So you know how a AC generator looks, how a DC generator looks. So what is the difference between the 2? Okay. So what do you think here? So remember, what does the AC generator use? The AC generator uses slip rings, right? And what does the DC generator use? The DC generator uses split rings. So just like the DC motor, the DC generator uses split rings. Excellent. I see some of you are getting that answer, right? By changing this or by replacing the slip rings with split rings. So that is the change you need to make here, right? Okay, very good. Let's move on to the next question. What principle is the electric motor based on? Is it Fleming's left-hand rule, B, Fleming's right-hand rule, C, electromagnetic induction, or D, force on a current carrying wire placed in a magnetic field? So here it's asking what principle is the motor based on? What do you think will be the answer here? So I see some of you are writing A, I can see C, D, C. Okay, so I'm seeing a lot of different answers here. I don't see a B, but I'm seeing A, C's and D's in the chat here. This is a very important question. Be careful. So the principle is Fleming's left-hand rule is not the principle. It only gives you, so the first one is not the principle, right? It just gives you the direction of the force. So Fleming's left-hand rule is not the key principle. It is just telling us the direction of the force. Okay. And what is what direction of force is it giving us? For the force on a current carrying wire placed in a magnetic field. So the correct answer will be D. Okay. Because the motor is based on the principle. Okay. Or what concept, right? the concept is that when you place a current carrying wire in a magnetic field, so when a current carrying wire is placed in a magnetic field, okay, so you guys know this, that when you have a current carrying wire and let's say you have a magnetic field, okay, you know that the current carrying wire will experience a force. Just like we saw when the electrons flow in a magnetic field, they will experience a force. Okay, and you know that force is maximum when they are in a perpendicular direction. So the principle is this, or if they ask you what principle, please write D. Don't write Fleming's left-hand rule. That only gives you the direction. Okay, so take care of that answer. It's going to be D. Let's move on to the next question. A convex lens of focal length 20 centimeters and a concave lens of focal length 50 centimeters are placed coaxially. What is the focal length of the combination? Okay, so here we have another question where two lenses are placed together. So we have convex lens and a concave lens, right? And the convex lens has a focal length of 20 centimeters. And for the concave lens, the focal length is given as 50 centimeters. Again, the sign convention is important. So should we write plus 20 or minus 20 plus 50 or minus 50? Please take care of that. You know that a convex lens has positive focal length, right? Okay. And a concave lens has negative focal length. Okay. So here we need to write minus 50 for the concave lens. Now we need to find the focal length of the combination. So can I just add it up? Can I do 20 and plus minus 50? 30? No, I see some of you are writing that answer. That won't be the right answer because remember, like we discussed earlier in this session, that we cannot do, if you do F equal to F1 plus F2, that's wrong. You can't add the focal lengths. Okay, what we can do is power. So we can add up the powers here. So I can say P equal to P1 plus P2. So we can add up powers and then from that we can find the total focal length. So let's go ahead and do that. So what will be the power of the first lens? So let's find that here. So P1 is going to be 100 by F in centimeter. Remember the formula? Either it's 1 by F in meter or 100 by F in centimeters. So this power is going to be 100 by 20. Okay. So that's equal to plus 5 diopter. Am I right? Okay. And this one is going to be P2 is again 100 by F in centimeters. So that's going to be 100 by minus 50. Okay. And there we have minus 2 diopter. So that's the power of the second lens. So 100 by 20 and 100 by minus 50. Now you add up the two powers. So now we can confidently add the two powers, 5 diopter and minus 2 diopter. So what will the total power be? It's going to be the total overall power is 3 diopter. Okay. So that's how you do that. So we've got till the total power, but we are asked in this question to find the focal length of the combination. So that should be pretty simple because we know F equals 1 by P if we want to find it in meters, right? So here it's going to be, F is going to be 1/3 of a meter, not centimeter, because either you use the power formula. So note, power has two formulas. Either it's 1 by F in meter, right? Or it's going to be power is 100 by F in centimeters. So use the right one here. So here we just use 1 by P. So we got the answer in meter. So the total focal length is going to be 100 by 3 centimeters, which is equal to 33.33 centimeter. That is our answer. Okay. So this is a important question of how to find it. I see some answers of 3, but 3 is the total power. Remember, we need to find the focal length of the combination. So don't forget to see. Good. I see some of you have written 1 by 3. Siddharth has written 33.33. That's right. Again, don't forget the unit, Siddharth, right? You need to write 33.33 centimeters. Okay. The unit is very important. Guys, don't forget it in the exam. You don't want to lose marks for a simple unit. Okay. Let's go on to the, anyone wants to see this working? I'll just show you again, right? So did you get that? Where power was 1 by F. And so we found the focal length after finding the total power. Again, add up, you can add up the powers, but you cannot add up the focal lengths. Okay, so let's go to the next question. We just have 2 more questions to go. So it's a 1 hour session. and give two advantages of hydroelectric power plants. Okay, so again, I told you advantages, disadvantages in the sources of energy chapter, very important. So hydroelectric power plants, what are the important advantages? One very important advantage is that these are renewable. It's a renewable source of energy, right? So because the river water and the water keeps flowing into the hydropower plants, and it's a renewable source. So that is a big advantage of this. And the other very big advantage, is that it is non-polluting. So it's eco-friendly. I'll just write that again. It's eco-friendly, which means non-polluting. Okay, because you know that in hydroelectric power plants, unlike thermal power plants where you need to burn up coal, so there's a lot of pollution caused as a result of that. But in hydroelectric power plants, the advantage is they are eco-friendly. They do not cause pollution. So again, these are, think of the most important points that you can write when writing the advantages. Okay. Let's go on to the next question. And actually, this is our last question, so let's attempt it. How will the heat produced in a resistor change if the current flowing through the resistor is doubled? Okay, so what is the question given? That if you have a resistor, right, and current is flowing through the resistor, now the question says the current in the resistor is doubled. Okay, so we have the same resistor R, but now the current is doubled, and they're asking how will the heat produced change, right? So note the question. So they're talking about how will the heat produced be changed. Okay, very good. I can see some of you are writing I see Bhargavi has written the correct formula. So which formula should we use here? Joule's law of heating, right? Akshat Swami has also got the right answer. So because we know that it's going to be H equal to I square RT. Right? No, it's not going to be doubled. We need to apply, this is the Joule's law of heating. Okay. And so if H equals I square RT, so if you double the current, right? So there's going to be a 2I square here, right? Can you see the square? So the heat, if this is the heat in the first one, then the heat in the second one, H2, is going to be 2I square. So it's going to be 4I square RT. And if you, the easiest thing is just do a simple ratio. If you do H2 by H1, can you see? It's going to be 4. So the heat produced is going to be 4 times more heat here. That's our answer, right? Because it's the square of the current. We doubled the current, so you can guess. Very good. I see Sahil Khatri has got the right answer. AB the gamer has got the right answer, 4 times, right? Excellent. So because here it's the square of the current. So always, because you'll be getting multiple choice questions in your test. So treat these questions, as small sums. Don't just try to guess the answer. Think what's the formula, apply the formula, solve it in rough. And then once you work it out, it's really easy, right? Very good. I see Khushi, Sarfuddin, they've all got 4 times. Debashish Bose, right? Very good. So the answer here will be 4 times. Okay, and that brings us to the end of our session, and it's just going to be 9 o'clock. I want to thank all of you for joining us here. Thanks for watching, and again, wishing you all the very best for your exams. Go, as I said, go and do your best. This is your time. Work hard, focus, and just give it your best shot. Don't worry about other things. Don't worry about the result, and that's not in your hands. Just go ahead and do what's in your hands. And guys, please do like, if you like this live session, please hit the like button, and do give me your feedback in the comments. And as I said, I'm sorry I couldn't reply to many of you while I was going over the questions. So I look forward to reading your comments and any feedback that you have, because this was our first live session. I thoroughly enjoyed it, and I hope all of you enjoyed it as well. So please let me know your feedback in the comments, and do share out. If you found this live session useful, please share it out with your friends so that they can also benefit from this. So, share it out on WhatsApp, Facebook, and just share out this live session, because it's that way it'll help more people, and it's always great to read your comments. It's really a wonderful thing that to read all of your comments, and it's very motivating, really. So thanks a lot. I hope you found this session useful, and all the very best again for your exams. And do check out our website also. You can search for it. It's manochaacademy.com. And if you haven't subscribed to my channel already, please hit the subscribe button right now, and click on the notification bell to get notified about new videos. We'll soon be uploading more maths videos as well, so do watch out for them, and we'll keep uploading new videos on our channel. So and I do hope you'll keep watching it. And once again, thanks a lot for your awesome support. I just want to say a big thank you from all of us on the Manocha Academy team. Really, thanks a lot. Thanks for your love and support. Okay, guys, bye. I'm going to be signing off. So take care, and thank you for the comments. Thank you. Yeah, thank you. It was a great session. All right, all the best. Keep studying. Okay, guys. Thank you then. Bye.